Hello everyone and welcome back to the 1 Minute Arduino. Today's sensor is the water level sensor, and we're going to see how water level sensor works and how to interface it with Arduino. If you have ever had a water heater explode or ever tried to make submersible electronics, then you know how important it is to detect when water is around. With this water level sensor, you can do just that. The sensor can be used to measure the water level, monitor a ENSEM pit, detect rainfall, or detect leakage. Now let's move to the hardware overview. The sensor has a series of 10 exposed Cooper traces, 5 of which are power traces and 5 are sense traces. These traces are interlaced so that there is one sense trace between every 2 power traces. Usually these traces are not connected but are bridged by water when submerged. The series of exposed parallel conductors together acts as a variable resistor, just like a potentiometer, whose resistance varies according to the water level. The change in resistance corresponds to the distance from the top of the sensor to the surface of the water. The resistance is inversely proportional to the height of the water. The more water the sensor is immersed in results in better conductivity and will result in a lower resistance. The less water the sensor is immersed in results in poor conductivity and will result in high resistance. The sensor produces an output voltage according to the resistance, which by measuring we can determine the water level. The water level sensor is super easy to use and only has 3 pins to connect. The S signal pin is an analog output that will be connected to one of the analog inputs on your Arduino. The plus VCC pin supplies power for the sensor, and it is recommended to power the sensor with between 3.3 volt to 5 volts. The minus ground is a ground connection. Let's hook the water level sensor up to the Arduino. First, you need to supply power to the sensor. For that, you can connect the plus VCC pin on the model to 5 volts on the Arduino and the minus ground pin to ground. However, one commonly known issue with these sensors is their short lifespan when exposed to a moist environment. Having power applied to the probe constantly speeds the rate of corrosion significantly. To overcome this, we recommend that you do not power the sensor constantly, but power it only when you take the readings. An easy way to accomplish this is to connect the VCC pin to a digital pin of an Arduino and set it to high or low as per your requirements. So, we'll connect the VCC pin to the digital pin 7 of an Arduino. Finally, connect the S signal pin to the A0 ADC pin on your Arduino. Thank you for your attention.